Good evening to all. In this video we continue EDA Tool Series, and this is a part 4 in which we are going to discuss the Cadence NCLaunch. It is similar to VCS, which gives the simulation compilation like that. So to start with this, we begin with our presentation and check how many commands are for the compile, elaborate and the simulation, and what are the formats for it, and how we can do these things on the terminal. And more important, we can go with the GUI also, but I am trying to have the process of the generally company standards, like they are trying to make some TCL files or make file through which they compile, simulate like that. So we start with that. Okay, we on the presentation just check the yes, this is a EDA Tools Series part 4 in which we are going to NCLaunch simulation commands and the TCL file generations. So basic commands are very similar to VCS. Generally we need first compilation, then elaborate, simulation, and then the GUI launch, that is NC-GUI. The command is simple: NC-VLOG, then NC-ELAB, NC-SIM for GUI-GUI. The examples of command is simple one: NC-VLOG dash file list.f. Then elaborate, NC-ELAB. There are some flags are there, like access plus read write C and name of the top module. For the simulation we need NC-SIM, name of the top module and the TCL file. Okay, so the example of commands: NC-VLOG -files netlist.f for compilation, elaboration, NC-ELAB. There are some flags are there and the top modules, and the for simulation NC-SIM, name of the module and some input from the TCL file. So we need to compile in a sequence, like compile, elaborate, simulate, like that. So there are two ways to make it, like either from the make file or from the TCL file. So I generally prefer the TCL file for this NCLaunch. My way of making a setup for the NCLaunch is I describe here, like make a folder name like NCL or any name you can give it. Under that name I generally create one code folder, and in that code folder I place the codes for which we are going for the NCLaunch, like compile, elaborate and the simulation. So and this NCLaunch required two files, cds.lib and the sdl.var. So the content of the cds.lib and the sdl.var is shown on this presentation. So generally we need this as a static one, so don't bother about it, you just place, because it's required by the NCLaunch. And the NCL folder look like to be like this. It has code folder in which all the files will be there. One cds.lib file that contains this much of text, and this sdl.var, it contains this much of text. So I create one bash file, like generate nclaunch.tcl.sh. so this bash file take the proper arrangement for the creating the NCLaunch script.tcl with the help of the syntax that NCLaunch requires. It took the code's details as well as the path of that, like To create that NCLaunch script, we have to just run the generate NCLaunch tickle.sh script, and it will create one NCLaunch script.tickle. For evoke the NCLaunch, we just need to type a command source NCLaunch script.tickle. The script contains this much of code. It will create one work folder inside that NC folder, and it will take every code from this code folder. I just put two code for AXI light slave and AXI light test bench for that. So it will create two lines NC Verilog, some input as a CDS lib, then some flags, how many lines blocks will be it will show like 15, and there is some work.axi light slave. These are the name of the file or module and the path of that particular source code. Similarly, whatever may the number of source files are there, it will create for the similar things. And NCVlog 2 times, NCElab 2 times, and then it will launch the NCLaunch, and it will NCSim with the GUI. These are the syntax that generally NCLaunch use. Maybe you refer your own upgraded or whatever version you have for the NCLaunch, but it is similar feeling that it is we are running the VCS, but only syntax have changed for the command execution. So please subscribe my channel, support me, and make a comment for the any feedback, and please hit like button. We start with the terminal window from the Linux, through which we can execute all these steps. Okay, so we are on that NCL folder. I just check what it contains. It has CDS lib file, HDL.var file, and the script, that is bash script. We check the wing for the CDS. Okay, let it be. We already seen that in the presentation, so no need to. We just create the run that generate NCLaunch tickle.sh. For running that, you just name that. So, and also we have to place the name of the test bench, module AXI light. I think this is the name. So it will create one script, that is NCLaunch script. We just check that NCLaunch script. As I told, it is what we seen in that particular presentation. Okay, so to run that script, we have to just make it source dot NCLaunch script. It will start running that complete process, like elaboration, then compile, and then elaboration, then sim. Okay, and it will launch the GUI for the NCLaunch. It is very simple as compared to other tools. Okay. We are waiting for that particular window. This is first window of NCLaunch. This is the design window, browser, and the console. These three windows will be pop up. If you remember our AXI slave light, I took the same code for this EDA exploration. After the design browser, you just select the module to see on the waveform. So just select the test bench module. Either you can select this button, or you can right click on that and send to the waveform window. it will pop up one window where we seen all these signals there. Please go back to that my AXI slave module, light slave AXI slave module, and check their details, okay, under the AXI series. So one pop-up waveform window will be pop-up. One additional signal I need, so the memory I need, you just add this button. Using this you can get these things. So you just click on the run button, and there is some zoom icons are there. You can zoom fit. Again we can check the cursor transition, okay, using these two buttons. Again we can have the causes of that. We can go to the cause of the means there is a transition on this signal which make logic 0 logic 1, and it will trace back to the source file where it is happening, okay. So it is a very innovative approach to track down the source file according to the transitions. And one more important thing is also there is one schematic generation for this same. You can go to this, send to the, it will create one pop-up menu for the schematic, not a netlist schematic, it is a front-end schematic, okay. And double click it like that. In this way you can also, if you want to trace back, you can also trace this, okay, like that in source. In this way you can trace back these things, okay. So I hope this video is useful for you, and please subscribe my channel. I will bring much more other EDA tools for you. Thank you.